Welcome to Integrating Coding in K-5. This is the first session in a series of sessions on integrating coding in elementary grades. And my name is Chad Moat. I'm going to go to the next slide and talk about my background a little bit. So I started out as a high school science teacher long time ago, and started noticing all of these instructional technology gadgets coming out, and I needed to get caught up and be current. So I entered into an instructional technology program at UGA, and then began to incorporate technology in my classroom, and began with ebooks and those kinds of things, which are very prolific now, and got turned on to coding. And we had my students coding simulations. First, we started out in Scratch, and they were playing various games and looking at different processes and phenomena in science. And we began to incorporate coding into the classroom by connecting what was happening at Georgia Tech in a particular scientist lab. Then went to Penn and actually began to research this a little bit, and worked with the MIT Media Lab and the Scratch group there in the Lifelong Kindergarten group. We were looking at virtual communities and collaborations online. And in particular, we had two different projects. One was focused on modifying music videos and music in general, and some of the coding applications that were geared around that. Another project was around STEM video game design, and that was my first stint with working with elementary grades. And the difference there was I could see the application to this to many different subjects, and that's when I became interested in looking at how coding can be used to bolster science and math content in particular. So we ran a workshop for a while with 4th and 5th graders and middle school students, and the students wound up submitting their games online to the National STEM Video Game Challenge, which had just opened up, and that's a online competition. They offer awards and different things like that, and the kids just build video games, and they can use different languages and submit those projects at the end of, I think it's by August, and there are about 5,000 games submitted each year. And so then I began to see the application there. So we had students building these video games, and they were linking the science content, and that was just happening naturally and because they were STEM video games, but they were actually integrating what they were learning in science. So I was like, hey, we can really build on this to build out some academic content, but also in technology classes to integrate coding and learn introductory coding. So it all meshed. And now I'm doing quite a bit of this with just various schools in Georgia. So that's my background. Feel free to contact me anytime. It's chadmode@gmail.com, and we'll go ahead and get started. So this whole series of workshops are tailored around K-5 and any subject in K-5, including technology courses. There are a number of technology courses that are state approved in Georgia now. And, there's a computer literacy class. There are actually some STEM exploratory classes, classes like that that are geared around technology, including media arts. So those are some exciting courses that coding could be integrated into as well. And also specials. I mentioned fine arts. One of the schools that I worked with, we focused on visual arts, and the visual arts teacher was a master at working with the academic courses and academic teachers, and working her projects and teaching her projects around what was going on in the classroom. So she did quite a bit of graphic design and projects in her classroom and connected what was the content standards from mainly science and math, but she also included ELA and social studies. So that's when I began to see the utility in integrating computer programming from the school level perspective, in scheduling and ensuring that the teachers have common planning time so that they could work on these projects in any classroom and in a way to where the coding and some of the applications of technology could be incorporated, but the students aren't spending all of their time on the technology. We're distributing this learning across many courses and in the rotations throughout the day so that these were long-term projects. And over time, what we found was the students were able to learn at a much deeper level. So the series of sessions and webinars in this these 10 sessions will be geared around that. And so I'll be trying my best to show the application of coding to multiple subjects and multiple courses. So if you're a teacher who is excited about the utility of coding and what can happen in the classroom, you're going to be wondering, what can I do to plan my lessons, develop my curriculum, work with other teachers, and gain professional development that's going to support my work. So I've put together a list of resources to help you in that process. One of the first places that I would suggest that everyone go is the DOE website and the computer science website in particular. So I'm going to share this screen with you, open this up, and we'll take a look at that first. Okay. All right, can you see this okay? Just thumbs up, yes, if you can see the screen. So on the computer science webpage, you can see just an outline of what's happening in K-12. Lots of exciting stuff happening right now. There are many folks who are working on developing computer science standards for K-8. And so look for that to be coming out soon, over maybe in the next few months. You can see over here for teachers and administrators, professional development that's available, curriculum resources, supplemental materials, and actual full curriculum. And they're not just high school, which is sometimes what we tend to think. So the other thing that you're going to be wondering is, well, what would I use to serve as a guide for me to incorporate coding, whether that's in a technology class, whether that's in a specials class or an academic class. And I do recommend that you work with other teachers on this and do a common project so you can do this in a way to where you're spending an extended period of time on a particular subject and project, and you can begin to look at some of these frameworks here. So I like this website. These are the frameworks that have been put out at the national level. You can see that these are across from K-12, so the vertical integration is there. There are concepts and practices and the whole framework if one is interested in reading that. You can see K2, 3, 5, 6, 8, 9, 12 here, and actual by the end of 2nd, 5th, and 8th grade, what the kids should be able to do with these practices. So computing cultures in the classroom and online, and actually taking the perspective of kids that are different from us, collaborating around computing, defining problems, using abstractions, creating computational artifacts or projects, and then refining those projects for various audiences. So that's important for social studies and English language arts. And then communicating those projects and communicating with others about the artifacts that we're creating. So that's a great starting point to think about how one is going to incorporate coding in the classroom. This is actually how the webinar series that I've been putting together is organized. Not laid out exactly in this way, but this was one of the first things I did was revisit all of these. So these were put together by the foremost experts in the country, and there were states that were involved. Georgia was involved, and our program manager at the DOE, as well as many of the virtual specialist folks that were included in that, and a number of folks at Georgia Tech as well, but other universities. So this is good stuff. Concepts, we can see some of the concepts here. I'll talk about the computer science standards in a second. And these were the practices. Okay. So this is actually I'm downloading this. This may be the whole framework. Yep, 307 pages. And you can see these are organized by practices and the people that were involved, the writers, and some of the advisors here. So some of those people may be familiar with. And then this breaks down some guidance for developing standards and the curriculum, the pathways, and teacher development stuff. So this is more of a framework to guide standards development and curriculum development, but a go-to source. And I just showed you guys that. These actually can break these down by the end of grade 12, by the end of grade 12. Let's look at 2nd grade. So in 2nd grade, much of this is learning about devices, the hardware and software, how to troubleshoot, the security pieces. That's really important for the younger kids. My daughter is 5, and so I think about this all the time now. What does she have access to? What can she handle at that moment from an emotional level? She's a 5-year-old. She has the feelings and the emotions of a 5-year-old, and she's operating on a 2nd grade level. So how does one, she's able to process all of this information, but at the same time, can she handle that on a socio-emotional level? And then we have devices and wireless devices, cell phones, connection points, and how all that works. So those were the frameworks. Let's look at the computer science standards. And so currently these are being developed, or the phase of development now in Georgia, which is really exciting because thus far at the K-5 level, we really haven't had a lot to pull from. You can see these are, let's look at this. This shows you ages 5 through 7, what one would expect second grade students to do by the end of second grade. And these are organized by what I was showing you earlier in the frameworks: the cybersecurity, the troubleshooting devices, and then some of the coding related aspects: algorithms, variables, control, visualization, transformation, that kind of thing. But here you can see level 1B, ages 8 to 11, and then 11 through 14. So I'm going to try to make sure that we're crossing K-5 whenever I'm discussing these. And then here we're seeing culture, social interactions. I don't know if you guys have been paying attention to some of the things that are coming out with social media. So there's been quite a bit of research that's come out that's showing that we need to be paying attention to the amount of time students are on social media and how those interactions are occurring. Something that as teachers we've known for a long time, but it looks like it's going to be on us to definitely help them navigate that world in a way that's healthy. Okay, just check back in with you guys to make sure that nothing's going wrong. Thumbs up still for everyone, and feel free to jump in at any point. Okay, so I have the frameworks. I've read all 307 pages, or at least looked at the table of contents and seeing some of the areas that maybe how I could organize and think about my curriculum in K-5. And now I need to begin to think about the tools that I can use, what's out there already, what programming languages are available to my students that are age appropriate. And then what are some communities, and I touched on that a little bit about social media. What coder communities or virtual online communities that I could leverage for motivational aspects, for the communication piece, for presenting projects and sharing and modifying projects in a way that's safe. So there are many out there. Not as many on the community side that I would necessarily recommend in elementary school, but definitely a number of them. The first that comes to mind for me is Scratch, and sorry, get out of this for a second. And which is a massive coder community. And not that everyone is coding at very deep levels all of the time, but there are a few million users, and there are millions of projects, over 10 million projects the last time I checked, that can be tapped, even if, as a teacher, if I'm not, having my kids coding in the classroom yet, but maybe I want to look to see what projects have been incorporated in the classroom or are available that could actually help my teaching anyway. But Scratch is a good place to start. And then if I'm teaching K or kindergarten or first grade and even second grade, although I've seen kids as young as second grade use Scratch, but Scratch Junior is available for the younger kids. And that's a coding app that's a kind of a drag and drop application where the kids are connecting, kind of like connecting Legos, but they're connecting the visual programming language in blocks, but in a way that's easier for the younger ones, where they're not having to use the mouse and click and point and do those kinds of things as much. And then there's also code.org, which has some full curriculum and is organized really well. So let's just start with Scratch. So we see here, Scratch is a community, it's a platform, It's a programming language, and it's a place to go to for kids even outside of school, and that's where most of this occurs for them, to begin to build their an identity really around the things that they're interested in and to create stuff. And so in elementary grades, that's hugely important and very motivational for them. Let's look at Scratch Junior. You can see here the applications that are involved, lots of video, lots of focusing on a few constructs or a few things that the kids can grapple with: animals, plants, movement, shapes, those kinds of things that are in the standards in the younger grades. You can download Scratch Junior from the Apple App Store, Google Play, Amazon, Chrome Web Store. So these are available for tablets and very easy to use. Okay, so code.org, this is one particular game or activity that is available. Let me go back to these. This is an actual course, Basics of Computer Science. So the homepage of code.org, you can see learn, teach, project, stats, those kinds of things. Going straight to the teach button. These are courses that are ready to go. They are already made and one can download those. There are guides to help teachers. There are activities that are set up, and there are actual courses online for kids to do. So the one that I was looking at was the fundamentals. Let's say course A, that's the one. All right, so here you can see some of the coding terms: sequencing, debugging, programming, loops, those kinds of things. And you can see it starts out oftentimes with just a video. I think this is the one we had earlier. And then here, I'm wanting to move the Angry Bird around, so I'm going to go east, and then I'm going to go north and see if I can interact with this guy up here. And then I'm just running this. I wrote 2 lines of code. Check it out. 4 lines total so far, so it's keeping up with that. So the idea here is that the kids are learning movement and how to get their script or the bird to their sprite, so to speak, to move around. I don't even know where I was going with it. But I think also the kids are able to differentiate up, down, right, left, north, south, east, and west. So these are just great courses and activities because they are organized and they are there's a lot of support materials for them. Let's go back to Scratch Junior. If I'm a teacher, I want to see what's available here and actually begin to see how this overlaps with my standards. In technology, these are in technology-related courses. These are going to be applicable very much to what's happening what's very much happening for those in that classroom, but also the standards of the technology course. But you can see that these are playing around in any order you like. There's a video introducing this, running a race, driving across the city. So here we can apply animals, different types of mammals in this case, ecology, some of the science pieces. Here looking at earth science, and then also sports for our physical education folks. And for the little kids, we're always focused on movement as well. Some of the social pieces, meet and greet, how does one go about interacting socially in a way that's appropriate, a way that's open and inviting, and having conversations. So all good stuff for kindergarten and first grade. Here, say what? Let's go to the next slide. These were the curriculum resources. I wanted to go to Scratch Ed. Scratch Ed is it's a support. It serves a support function for the teachers that are incorporating Scratch into the classroom, and it's developed by a group. There's someone from Harvard. It's a Harvard and MIT partnership. Also other folks that have worked on these from other universities, and some practitioners in K-12 where many of these activities have been incorporated in the classroom. But this is actually an introductory computing curriculum with Scratch. And we said earlier that Scratch is appropriate for students ages 8 to 16. Scratch Junior, ages 5 to 7. On the code.org site, you saw that there were curriculum for students all the way from K to 12. Okay, that's still downloading. This says ages 8 to 16, and that's what the program and the virtual coder community, the platform, is designed for. But it's not unusual for computer science professors at the college level to incorporate Scratch just to show the visual language and compared to other types of languages that are there. Okay, so just wanted to show you this guide for launching a Scratch course and a curriculum, and embedding this into your current curriculum, pulling pieces of it, modifying to suit your needs. Again, going back to a long-term project that kids could work on, and you could begin to do some cross-collaborative planning with other teachers in your school, or as a K-5 teacher, you're most often you're not departmentalized all the way down. You'll see some 5th and 4th grade grades that are departmentalized often in schools, but that makes it more challenging. But also, if one is working on a computing project, then that's portable from classroom to classroom, across science, across math, across ELA and social studies, and then into the specials classes. So these are broken down by units. Exploring, and this is geared around movement, that kind of thing. Animation, putting a series of scripts together to do something. And then stories, so actually getting into the perspective of characters, conversations. This one is, I would highly recommend for English language arts. And then games really brings out some of the creativity of what kids can do. Unit 5 and 6 are more advanced, more complicating code is written and modified and debugged, and some troubleshooting going on in these activities. Okay. So just to reiterate, if one's beginning to incorporate coding into the classroom, you have the frameworks you can pull from to help guide how you're thinking about the curriculum and the activities that your kids do. The frameworks are highly applicable to just what you're doing in the classroom anyway. And then it brings in those computer science elements. And then we have the K-12 standards, and soon to come out over the next months or next year would be the Georgia standards for K-8. I'm not sure when those are coming out, but I know that everyone's looking forward to that. And then these are just a few places to get started with. So next time, we'll talk more about Scratch. Scratch Junior is an application, so I'll focus on Scratch more next time and actually begin to look at the community itself and some of the ways that Scratch can be leveraged into the classroom. And so just for homework, go ahead and create a Scratch account by the next time we meet. Next, which will be, I'll have to give you the date on that. But you'll go in and then choose your Scratch username and a password, and then we'll get started. You can contact me anytime. And again, my email is chadmode@gmail.com. And I look forward to seeing you guys next time.